Hello everyone, welcome to Euron. In this video, I'm going to discuss about a roadmap for MLOps engineer in this entire ecosystem of data science or AI. So obviously machine learning engineer exists, deep learning engineer exists, computer vision engineer, NLP engineer, Gen AI engineer exists, but there is a separate category of engineer who also exist in this entire ecosystem of data science and AI, and that is called as ML ops engineer, machine learning operations engineer. Now what they do, by the way, so obviously you have built a model, you have gone through a data set, you have already build the final version of something which is producing a result, but you have to host that model, you have to deploy that model. That model is going to get maybe a hit of 10,000 or maybe millions of queries at a time in a fraction of second, and obviously you have to scale that particular model, and this is where these kind of an engineer, ML ops engineers, comes into a picture. So in this particular roadmap, I'm going to discuss about it. So let's share my screen, and here is a roadmap to become ML ops engineer. Now step by step I'll try to move, so starting from a fundamental or foundation and then getting into a in-depth of it, or we can say advanced part of it. Okay, so I believe my screen is visible to all of you and fonts are readable, I'm assuming. Okay, so to get into anything, right? To get into anything, I keep on advising people, I keep on suggesting people that always try to start from a basic. Now, foundation, because if your foundations are not strong, you will not be able to excel in any field. Believe me, in any field, not just in this field. So here, to become a MLOps engineer, first of all, a foundational machine learning should be very much clear to all of you. Now inside machine learning, supervised machine learning, unsupervised machine learning, semi-supervised machine learning comes into a picture. So this is the topic which I have mentioned over here. Let me iterate through these topics one by one. So basic of machine learning, so type of ML, supervised, unsupervised, reinforcement learning, and its evaluation matrices. At the end of the day, whenever you are going to create a model, obviously we try to evaluate those models and then we try to put all of those models into a production. It's not like I'm just going to build something and then I'll just go and push it into a production. No, nothing like that. Now, core ML algorithm, regression algorithm, logistics regression, linear regression, decision tree, random forest, k-mean, devious scan, which is basically a clustering algorithm, gradient boosting like a XGBoost, light GBM, all those things you are supposed to understand. Then model development process like data processing, feature engineering, model training, validation and testing. These are the things which is very, very basic, because this is something that you are going to do with every model, not just with a couple of model or one or two. No, so without any exception, you will end up doing all of these things with every model that you are going to encounter. Okay, so tentative number of hours that you can try to spend over here is a 40 hour maybe. Yeah, but more or less it is going to take time, depends upon your capabilities. If you are already aware about machine learning, then you have to just go and revise it. That's it. Nothing more than that you have to do. Just go and revise it. But if you are not aware about it, all of these things, and if you're aware about it but on a very, very basic level, so in that case I'll recommend you to go ahead and then try to revise it in depth, practical way. Now, programming and automation skills, because you will be a part of operations. Programming is important, operations wise, and automation skills are important. So here, Python for ML, that is something that you are supposed to know. Library wise, NumPy, Pandas, Scikit, TensorFlow, PyTorch, again these libraries are very much important even for a data science. So even in my data science roadmap, I talked about it. Writing a modular and reusable code, this part is important. People generally think that I'm going to write something into a Jupyter notebook without following the package or modular coding, or maybe a code that can be used by someone, and then I can push things into a production. No, not at all. Not going to work in this way. Now, data handling, exception management, all these things, because things can go haywire into a production. Now, scripting and automation. So bash scripting, basic, important and very, very important, where you will be dealing with a Linux command. Task automation with Python. So yes, with Python, everything can be done. Everything means literally everything can be done. Whatever you can imagine, you can do it inside a Python. There is a library or there is a provision where you can write your own custom code. Now, versioning control, again important because you have to manage the code bases. So branching, merging, pull request, all these things are part of the Git. Working with a GitHub, GitLab, any of like a platform who provides a Git features. That's it. There are so many platforms who provides a Git feature. GitHub is one of the most famous one. The second most famous one is a GitLab. So I have mentioned over there, approximately 38 to 40 hour of time you are supposed to devote, or maybe complete 1 week you can try to devote. Depends upon your availability, guys. So I'm leaving this up to you. I'm not the one who can talk about this, by the way. Then where you will deploy your model. So obviously on a cloud platform, you are going to deploy the model. Yes. Or maybe on-prem, you are going to deploy the model. Maybe on a bare metal, you are going to deploy the model. So in general, we try to deploy a model on a cloud platform. So here, compute wise, for example, for AWS EC2 compute, and there are other computes, ECS, all those things are available. So you have to like think about it. You have to learn about it. Storage, networking, all these things comes into a picture. So recommendation will be to go ahead with AWS first, then explore GCP, and then explore Azure. So in this way, you can try to go ahead with a compute, storage, and networking. There are so many services available already inside AWS for compute, storage, networking. Same things exist on GCP with respect to a compute, storage, and networking, and on Azure. So just go ahead with that. Now, AWS for MLOps, like I said, focus on AWS. So EC2, my bad, Elastic Compute Cloud, Simple Storage Services, which is S3, Lambda, IAM role, SageMaker for ML model deployment. So these are the things that you should go through it. In AWS, there are 270 plus managed services are available. Managements, you will be able to get a platform inside a AWS kind of a dashboard where you can just click, configure the things, or maybe try to like write some sort of a code somewhere, and then it will be done. So AWS has made your job anyhow very, very easy, but you are supposed to explore that. Now, infrastructure as a code. So Terraform basic, you are supposed to know managing cloud storage resource programmatically. So how you can manage, because when you will go on a scale, so it's not just one single resources, there will be a different segment of the resources, from a networking side, from a storage side, from a compute side, from a security side, you are going to encounter. So that is important. You have to explore that particular part. Now, so cloud is done. Let's suppose I'm aware about the cloud. I'm aware about the basic of scripting, automations, and a machine learning algorithm. Then CI/CD for machine learning. Continuous integration and continuous development, because by default, doesn't matter whether you are going to work in a machine learning project, in any project, believe me, even a web development project, even a Java project, any kind of a project that you are going to build, everywhere this CI/CD is an integrated part of it. So you are supposed to be aware about it, that what is a continuous integration, continuous deployment, what in all platforms are available which you are going to use to achieve this particular goal, CI/CD goal. Then ML pipeline tool you can try to use. Maybe you can try to use a Jenkins, GitHub Action, or GitLab CI. GitHub Action, I will recommend you to go ahead with the GitHub Action and then try to explore a GitHub CLI and CI, and then try to explore a Jenkins. Then Kubeflow pipelines and Airflow. Again, for a scheduling, you can try to use it. And then testing and monitoring, because if you are trying to push something into production, obviously you will have to do a lot of testing. Your team will be having like a testing member, and who is going to test it. So unit testing for a ML model, model versioning, and a rollback. Because why I'm saying model versioning, because it's not like you will just build a model once and then dump it. No, you will keep on iterating it, keep on retraining it. So you have to build that particular pipeline as well as a MLOps engineer. So that is going to be your roles and responsibility. And if something goes wrong, so obviously you have to roll it back to the previous state where things was working in a perfect way. So here again, 42 hours of effort that you can try to put up. And then containerization and orchestration. Here you are supposed to talk about, or maybe you should know about, a Docker and Kubernetes. So Docker file basic, again, Docker is actually basic. You have to put up effort over here inside a Kubernetes. And again, so Docker and Kubernetes is the must for any ops guy, not just for a ML, I would say for every project, for every segment, and for every domain. And deploy a real-time model on a Kubernetes. So this is just a one-time job. Once you are able to do it, you will be able to learn, and then eventually you will be able to explore other feature which is available inside these particular things, Kubernetes and Dockers. Now monitoring and logging, again important part, because once you have already deployed the model, you have to do a continuous monitoring. If it is going to crash, maybe it is not going to serve the purpose, so you have to keep on monitoring all of these things. And this is where Prometheus, Grafana comes into a picture. This is where Elasticsearch, Logstash, Kibana, log parsing, all these things comes into a picture. Now statistical method for detecting a model drift. So if model is not behaving as per the expectation, so it simply means that model is drifting, and then you have to figure out a way, in a way where automatically system will be able to identify those cases as well. Now coming to the next part. So if you are able to do all the operations, how you can forget about a security and compliances, because security and compliances are must for any companies or even for your customer who is going to consume your model or services from your model. So security and compliances, that is something that you should know. You have to build the entire pipeline for that. You have to build policies for that. So here security APIs and sensitive data, key based authentication, obviously you have to implement for your internal team member as well as for a user. GDPR and data privacy consideration. So obviously country wise there will be a different policies and regulations, so you have to consider all of those policies, and then only you will be able to release your solution in that particular region. So obviously you have to consider all of these things. And then coming to the last part, end-to-end ML pipelining with CI/CD project. So develop, train, deploy ML model with the automated testing and monitoring. Everything can be automated, and this is something that you are supposed to learn, you are supposed to explore. Scalable model deployments means it can serve one user to 1 million user in a second. Depends upon your business use cases. Again, it's not like on a day one itself you will try to scale it up till 1 million. You will end up consuming unnecessary resources of your company, of your organization. So you should not even do that. So as your customer base is increasing, as a number of hits for a particular model is increasing, a particular system is increasing, so you have to scale in that particular way, and you have to build an autonomous pipeline, automatic pipeline for that one. Data drift detection system, I think I have already talked about it, but here, so you have to implement it. Scalable model deployment, end-to-end ML model with a CI/CD pipeline. And then, so this part is going to take a huge amount of effort, a 90-hour approximately you are supposed to invest. Once the above part is done, then this part is not at all a big deal, because whatever you have done so far, so forth, that is something you are going to mention inside the resume, right? So resume building, portfolio creation, networking, all those things you are supposed to do over here. And then final thing, start applying for the job, maybe for a permanent role or maybe for a freelancing work. There are every kind of a work which is available in a market, so you can keep on doing it. You can start doing a networking. Believe me, this helps a lot. Try to share your work with everyone, try to showcase your work with everyone on almost every platform that you know, almost all the social media platform, because you never know that where your next recruiter is sitting, right? And they will see your work, and if they have a requirement, they can try to approach to you, and you will be able to do your job, you will be able to get your job, right? So this week onwards, means 6 months onward, you all will be ready for a ML ops engineer. Simple. You can start applying for the job, and you can keep on brushing up all the topic. But at the end of the day, I always advise people, or I always advise my students that always try to focus on projects, practical work, even though it is going to be small in a beginning, because this is how you will grow. But try to focus on a practical side of it every time, because that is going to give you a result. Because of it, you will be able to secure a next job. Yes. So hope all of you are able to understand this part. Description, you will be able to find out this particular PDF. Let me know if you have any kind of a question. If you're looking for any kind of a clarity from my side, please comment inside a comment box. I'll try to help you out, and for sure I'll try to reply as soon as I'll get some time. With that, Thank you so much, everyone. See you again in my next video.